Alright, continuing with Chapter 4, Systems of Equations. Have your note packet out. Go ahead and open to where we left off. So we should be right here. And we're going to talk about solving a system. So let's do one to review where we left off and what was on the homework. So remember, the solution is where the points cross at. Okay, that's what we're trying to get to. So let's go ahead and graph this and solve. So I'll take this top equation. Solve for y. Divide by -2. Y equals 5 over -2x minus 4. Then I'll take this other equation, I'll solve this one for y. I'll subtract 3x to both sides. Divide by -2. And a negative divided by a negative is a positive. Plus 4. Okay. So make sure I got my straight edge. And I'm going to go ahead and graph these. So starting with this, I'm going to start at -4. 1, 2, 3, 4. Then I'm going to go up 5 and to the left 2. 1, 2, 3, 4, 5, and left 2. Okay. Draw my line. Over here, I'm going to go to +4. 1, 2, 3, 4. And looks like I'm going to go up 3 and right 2. Okay. And see where they cross. Looks like they're going to cross right there. The lines cross at the point that looks like -2, 1. Okay, so that is how you solve by graphing. This has some problems in that sometimes it's hard to be accurate. Maybe the intersection is really far away and it's hard to see. So we need some algebraic way. So that's what we're going to learn today, is how to do it by solving and not by graphing. Okay, so this is a different method to do the same thing. So if I go to the next page, I'm going to solve by substitution. Okay, so the key for this to work, okay, the main thing that we need to have is, to do the substitution method, you need to have one variable alone. Okay, one variable alone. Doesn't matter which one. You have to have some variable solved for itself. So typically we do y. So here's my system. So I'm looking at these two right here, and I got to find out. Now I could graph them just like I did in the previous example, but I want a different method. So the first thing is, do I have one variable alone? Okay, and you see I have this y all by itself, then I am good to go. Okay, so as long as that's true, then what I'm going to go ahead and do is, all right, now I'm going to do the actual substitution. So y is the exact same thing as 2x plus 1. That's what the equal sign tells me. So what I can do is that this whole thing is the same thing as a y. So I'm going to take it and I'm going to put it right there. Okay, and when I say put it, I mean substitution. So I'm going to rewrite this top one as x plus 2 plus 1 equals 4. So because they're the same, I can swap them out. Now if you look at it, I don't have a y anymore, so now I can solve this. So I'll combine like terms. Right, subtract to both sides, divide by 3, and x equals 1. So now I got to find the y value. So Now I'm going to do substitution again, but this time I know what x is, so I'm going to put it right there because now I know what x is. So I'm going to say y equals 2 times the x that I just found. So I get y equals 2 plus 1, and then y equals 3. So I found everything that I need. I'm going to say the lines cross at 1, 3. Okay. Substitution property. So let's just kind of go through these, and we'll do a bunch, and we'll clean it up next class. So let's go through the process one more time. I need to have one variable by itself, and I do. So I see I have this x all by itself. So now I can replace the x with that. So I'm going to take that, I'm going to put it in for the x now. So it's going to be y plus 8. Okay. Equals, oh sorry, y plus 8 plus a y, alright, equals 10. Now I combine my like terms, subtract 8 to both sides, divide by 2, and y equals 1. Now go back and plug in again, and I can plug in anywhere. I can plug in right there or right there. I like to do the one right here. So it's going to be, so there's my first part of my answer. X equals 1 plus 8, and x equals 9. So I would say the lines cross at the point 9, 1. Make sure you put the x first. The x first. Alright, substitution problem. So now, okay, we're going to skip this one here. We're going to jump to this next one. So we got the same thing. We need to have a variable by itself. Okay. So I'm going to look, and I do. I got a y all by itself. Okay. So now I can take this and put it into that y. Now you got to be careful here because there's a 3 out front. So what this, I'm going to rewrite this bottom one, and it's going to be 3, and instead of the y, I put this, and I got to put parentheses around it. And you can see here I'm going to have to use the distributive property. Then here I'm going to combine like terms. And then I'm going to add a 15 to both sides. Divide by 5. And x equals 4. So I'm halfway done. I got to find the other point. So I got x equals 4, so I'm going to put it right there, and then I'll work out the y. And y equals 2 times 4 minus 5. Y equals 8 minus 5. And y equals 3. So my actual answer is the lines intersect at the point 4, 3. Okay, so substitution method. Okay. We're going to go to the next page and do one more example. We'll save the other ones for next class. Okay. And so if you flip the page here. Okay. And I'm actually going to do this bottom one down here. Okay. So what it also tells us to do is check by graphing. So when we're all done, we're going to graph it as well. Okay. So I picked this one because it's a little more challenging. So if you look at it, the problem is no variable is all by itself. I don't have an x all y by itself or a y all by itself. I have to make that happen. And we can do it because we spent a lot of time solving for y's or x. I'm going to take this top one. I'm just going to pick one. I'm going to take this top one. Okay, and I'm going to solve for y. I'm just making that choice because I need to get some variable all by itself for this to work. So I'm going to go ahead and write that right here. And it's going to be good because I'm going to graph it when I'm done anyway. So I want to have that. So I'm going to add a 6x to both sides. Okay, and this is confusing for a lot of people because you have to decide to do this on your own. Okay, you could have took the other one and solved that one for y. 6x plus 2 divide by 2. Okay. And y equals 3x plus 1. So I could go ahead and graph it, but I'm going to wait. I'm going to continue with the substitution. So now I got a y all by itself. I got a y all by itself. So now here's a key. I got to take this and plug it into the y of the other equation. So I got to put it right there. So I'm going to take this and I'm going to put it right there. Okay? And so that's going to be negative 4. So I'm going to rewrite this, but instead of a y, I'm going to put this 3x plus 1. Equals 8. Okay, now I'm going to solve for the x. So I'm going to start by using my distributive property. Combine like terms. Alright. Just double checking everything here. Okay. And then minus 4 equals 8. Okay. Alright, then I will add 4 to both sides. $12. Okay. Then I'll divide by negative 16. And I got a fraction. And that's kind of annoying. But that's alright. But it reduces. I can take a 4 out of both of those. So it's going to be a negative 3 over 4. Okay, a negative 3 over 4. Alright. So that makes it kind of challenging because we have the fraction, but it's not going to be that bad. And what I'm going to do here is I'm going to take this one here, now that I know what x is, and I'm going to plug it in right there to figure out the other answer. So it's going to be, I'm going to do that right here. Let me see if I can move this up a little bit. Negative 4 times negative 3 over 4 minus 4y equals 8. And this is going to be pretty nice because I'm going to be able to reduce these. So I'm going to get negative 12 over 4 minus 4y equals 8. I'm going to divide these and I'm going to get negative 3 minus 4y equals 8. I'm going to add a 3 to both sides. And that equals 11. Divide by negative 4 to both sides. Okay. I'm going to go ahead and get a decimal on that so I can kind of see where it's going to be when I actually graph it. And the decimal on that is negative 2.75. And the decimal on this one is negative 0.75. So what I'm going to do is I'm going to go ahead and graph these. See what happens. Okay. So I got this one solved for y. So let me graph that. It's going to be a 1. I'm going to go up 3 and to the right 1. 1, 2, 3, 1. Okay. Okay. Now I'm going to take this one over here. I got to solve it for y so I can graph it. I can do the intercepts as well, but I'm going to go ahead and add a 4 to both sides. 4x. Okay. Divide by negative 4. And I get y equals negative x minus 2. So I'm going to go to negative 2. 1, 2. Down 1. Okay. To the right 1. So start from -2, go down 1 to the right 1. Okay, see if I can get these so I can here. Okay, sorry. Okay, and look for my intersection here. Okay. And if you look at it, it's a little bit off, but you can see here I can graph the point and be pretty close.